Battery, we got involved mid-2020. It was the first large-scale battery that we had been involved with. We'd been involved with a smaller 50 megawatt battery previously, and so the scale of this project made it strategic for us. So the work really revolves around building the connection application as required by AEMO, and that means building power systems models of the plant, tuning those models, making sure that then the models perform as per the rules, and then presenting those results to AEMO for approval, and then working through the various stages of approval and fine-tuning to get to the end point, which is the acceptance of the connection agreement. Along the way, we worked really closely with the OEMs, PE and Fluence. We've ended up in a really good spot, I think, in terms of using the inverter technology appropriately and getting some enhancements into the Fluence power plant controller that will set us up well for the next stage of the project. Grid connections in general across Australia are really hard to achieve based on the fact that our rules are more complex than rules in other parts of the world, and our modelling requirements are higher than in other parts of the world. And so almost universally, when newer OEMs enter the market, there's a period of time where the models need to be adapted and built up to the standard that's required in Australia. So the Hazelwood Battery Energy Storage System is important in the Victorian context for a couple of reasons. First of all, it's located in the Latrobe Valley, and so it's really nicely located in Victoria on the end of the 500 kV line, and also close to Basslink and the existing coal-fired power plants. So it's in a position where it can easily replace some of that existing flow as needed, but it's also well enough connected to the rest of the region, which is now quite renewables heavy, to be able to store some of that renewable energy during peak times and then discharge at times when it's not windy or not sunny. I guess the other part of the Victorian context is that they have had in the past series of days of high temperatures, and as that occurs, various power plants start to run into capacity constraints. So we know that there's some wind farms that overheat on hot days, but equally the thermal power stations end up having cooling problems because their cooling ponds start to warm up, and so then they face capacity constraints. And so the availability of storage within the region will be really valuable going forward. So when I think about the Hazelwood battery and our contribution to it, I feel as though our expertise has been central to the success of the project, and particularly in overcoming the rolling challenges that have come through from AEMO's due diligence process, and the ratcheting up of the requirements there. We've been able to technically meet those requirements and successfully get the outcome that we needed.